Hello my dear students, welcome back to NEET World, and this is our 5th session on our electrochemistry right now. So in the previous session we have covered conductance, conductivity, resistance, resistivity and molar conductance, equivalent conductance, the relations and previous year questions related to this discussion right now. Right, we have covered from EAPCET, NEET and also from JEE right now. So these are the PYQs we have clearly discussed related to these topics, and here in this session we will be discussing Kohlrausch Law. What we are discussing? Kohlrausch Law. Okay, so this Kohlrausch Law is also one of the very important topic for your EAPCET, JEE, NEET exams. Okay, so just listen to the session completely and be present here. Okay, listen to the session completely from the starting itself, so that you will not miss any of the discussion and you will get complete clarity on this topic. Okay, right, let us discuss the topic first, then we will do some questions after the discussion. Okay, right, look at here. So what is the use of Kohlrausch Law? First of all, see, if you read the definition of Kohlrausch Law, you will get one point here. See, at infinite dilution, okay, an ionic species, that it may be cation or it can be an anion. Okay, an ionic species contributes a fixed value at a given temperature towards total conductance of electrolyte, irrespective of the other ion in combination with it. It means what? See, we know there are two types of electrolytes. What are the two types of electrolytes? We know there is something called a weak electrolyte and a strong electrolyte. So give some examples for strong electrolytes and weak electrolytes here. Let me change the color. Yeah, perfect. Strong electrolyte and one more is weak electrolyte. Okay, give some examples here. Yes, you can take NaCl or acids like strong acid HCl and strong bases like NaOH. These are the things you can take for strong electrolyte. Okay, and these salts can be taken as NaCl or it can be MgCl2, like this kind of different possible salts are there. Those all comes under here strong electrolytes right now. So when it comes to weak electrolytes, yes, you can take the best example here, you can take weak bases like NH4OH, and next weak acids we have acetic acid, you can take as a weak electrolyte right now. So in this case, you know what I am saying, the conductivity, what I am saying, K, conductivity. When I talk about conductivity, the conductivity of an electrolyte decreases upon dilution. If it means if you are diluting it, dilution means what? Concentration decreases. What I am saying, concentration decreases. If concentration is decreasing, that is called dilution right now. So what is the formula of molarity? Molarity equals to number of moles of solute by volume. So upon dilution, it means you are increasing the volume. So upon dilution, concentration decreases, right? How they related? N by V means inversely related. Number of moles here in the numerator, volume here. So molarity and volume of solution are inversely related. So upon dilution, volume increases and concentration decreases right now. So when you decrease the concentration, conductivity K, that is what yesterday's discussion I am saying, conductivity decreases for an electrolyte, whether it can be a strong or it can be a weak. But when I say molar conductance or equivalent conductance, so these conductances, molar conductances, equivalent conductances increases upon dilution. It means, see here what I am writing, concentration here. Okay, so like this. So if I go this side, concentration value increases. If I go this side, it is 0 here. So it means if I go this side, what happens towards origin, the concentration will become almost 0. Okay, so now what is happening, the experimental observation is something like this. So it is observed that there will be a line showing like this. So what is this line indicating? So look at here what you are getting. Upon decreasing the concentration, it means I am moving towards origin side. See here maximum concentration somewhere I have started here. So slowly I am moving this side. It means what happened to the concentration? Yes, concentration is decreasing this side if I am moving. It means upon dilution. So upon dilution concentration decreases and the molar conductance is getting raised. Okay, so here you are seeing I am extrapolating the graph and I am reaching a point. So at this point, if you observe what is the concentration value here, at origin concentration is 0, right? So it means you are taking, it means you are adding water to that amount there is no interionic attraction between the solute particles, between that electrolyte. That is what zero concentration means here. So infinite dilution you can say, or infinite dilution you can say, or zero concentration of solute or that electrolyte. So at this point we will be seeing maximum conductivity, molar conductivity here. Okay, so this maximum conductivity limiting, you can call it as limiting molar conductance, or limiting molar conductance, or molar conductance at infinite dilution. So I can indicate that at zero concentration, yes, del naught m we can say. Okay, so this one, the drawing of this plot and finding the exact value, the molar conductance value at zero dilution, at zero concentration, can be able to calculate it only for strong electrolytes. It is not possible to get it for weak electrolyte, like there is no such graph explaining or giving the exact value of limiting molar conductance for a strong electrolyte. When you do it for a weak electrolyte, just look at here what I am drawing, root C versus del m. When you are doing it for this, you are going to get a graph something like this. You are going to get a graph something like this. Even if you are making it zero dilution, means zero concentration, or it means you are adding infinite amount of water, it means you are doing dilution to it. Okay, so upon diluting also you are not getting a exact value, it's keep on increasing, keep on rising, molar conductances keep on rising, but it is never touching this y-axis line, never touching its y-axis line. So it means what? You cannot calculate limiting molar conductance for a weak electrolyte. Why? Because weak electrolyte will not undergo 100% dissociation right now. So alpha value will not be equals to 1, or 100% dissociation is not taking place in case of weak electrolytes. That's why we cannot able to calculate the exact limiting molar conductance of these weak electrolytes. So now what we can do? Yes, we can calculate that limiting molar conductivity by some other method. That some other method is nothing but our Kohlrausch law. So what is the use of Kohlrausch law? Yes, the limiting molar conductivity of weak electrolytes can be calculated using an indirect method called Kohlrausch law. So what is this? A Kohlrausch law is an indirect method that is used to calculate limiting molar conductivity of a weak electrolytes. Okay, hope the discussion is clear. Now let me give you what is this Kohlrausch law and how it is explaining. For example, just tell me acetic acid is a weak electrolyte or strong electrolyte. We know acetic acid is a weak electrolyte. Okay, so the limiting molar conductivity of this acetic acid we need to find. Okay, but it will not undergo dissociation now, therefore we will not get the direct values. But if I take a strong electrolyte, for example I am taking HCl, this is strong electrolyte now. So when I say the limiting molar conductance of this HCl, then we can write it as the ionic conductance of H plus ion, because HCl will undergo dissociation to give H plus Cl minus right now. So you can write ionic conductance of this H plus ion plus ionic conductance of this chloride ion, that's it. Okay, like this you can calculate for strong electrolytes, but it is not possible for these weak electrolytes, because a weak electrolyte will not dissociate 100%. See, there will be an equilibrium or reversible reaction is taking place when it is undergoing a dissociation, like acetate ion and H plus ion form. Okay, so this is not a 100% dissociation. See, here single arrow I am indicating perfectly ionic, I mean perfectly one side, so 100% dissociation in case of strong electrolytes, but not in the case of weak electrolytes. That's why we cannot calculate for this weak electrolyte as like in this strong electrolyte. Okay, so what we need to do? Yes, we are going to use a method called Kohlrausch law here. I will tell you, just listen here. See, what I want to find here, the limiting molar conductance of this acetic acid. Okay, but that is not possible by taking directly, because these ions will not give 100% from this electrolyte. So now what I am doing is I am using Kohlrausch law. So what is this Kohlrausch law? Here I told you HCl. Similarly I am writing sodium acetate. Tell me, sodium acetate is a strong electrolyte or a weak electrolyte? Yes, it is a salt, so it is a strong electrolyte. Okay, you can write it as limiting molar conductivity of this cation, that is Na plus limiting molar conductivity of this anion, that is acetate ion, SCH3COO minus. Okay, and one more thing you can take, you got acetic acid, acetate ion and HCl. The next limiting molar conductance of NaOH I am using here. So what is the use of this NaOH? I will tell you. Okay, or NaOH, not NaOH, you can take NaCl. Okay, so that you will get limiting molar conductance of Na plus ion plus Cl minus ion, that's it. So these all which I have written here are strong electrolytes. See, in order to get the limiting molar conductance of this weak electrolyte, what are the ions we required? We required one acetate ion and one H plus ion, because when it is undergoing dissociation, see, if I directly take these values, I don't know. So the values, these values I am getting from these strong electrolytes which are contributing same ions as like this a weak electrolyte. See, the acetate ion can be given by a strong electrolyte here. This is sodium acetate now. Yes, it can give the same ion as like acetic acid. But here 100% dissociation, there is only partial amount. That's why I am taking the same acetate ion concentration coming from this one. Okay, so that you can take del naught of sodium acetate. Let me just give me few more minutes, then you will get complete clarity. Okay, and then next I want acetic acid. I have acetate ion. Okay, what is the extra ion here? We have sodium ion. Now we need to remove that. We will remove, and along with that I want H plus ion also, because H plus ion also given. So from where it can comes from this HCl. You can write del naught of HCl. Okay, and then next, what are the extra ions we have here? Yes, there are two extra ions, that is Na ion and chloride ion. So remove them, del naught of NaCl. That's it. Okay, so you have got, see, acetate ion, the next HCl. See, out of this I want only ions that comes from acetic acid, that is acetate ion I want H plus, but extra ions are what we have, Na plus ion is there, HCl is there. That's why we are removing it as minus NaCl. Okay, that's it. This is what the equation you should indicate for writing the equation. Okay, is this clear or not? Guys, if this discussion is clear, click on the like button, or else we will discuss few more points so that you will get complete clarity. Just look at here. Once again, what is Kohlrausch law? It is saying here that at an infinite dilution, an ionic species, that is what cation or can be an anion, will contribute a fixed amount of value towards the limiting molar conductivity of that particular ion. For example, here you can see all the H plus ions that may comes from any ion, whether it comes from weak electrolyte or a strong electrolyte. If this H plus ion is there, then the limiting molar conductivity of that H plus ion is around 350. How much? It is 349.6 now. Consider it as 360 for remembering purpose, and these are the units you can take. That is the ionic conductivity value here. Similarly, for sodium ion is this much, potassium is this much, calcium here, magnesium here, you are seeing. Okay. Now out of all cations, H plus ion will contribute maximum ionic conductivity towards the calculation. That is what limiting molar conductivity is shown maximum by H plus ion. Now out of all anions, our OH minus ion will give maximum ionic conductivity. How much it is? That is 200, that is 199.1 means it is a 200 value, you can remember. Okay, and remaining ions are something like this. Okay, so just remember H plus ion as 350, chloride hydroxide ion is a 200, that's it. Okay, right. The next thing here is, look at here. So what are the applications I am giving you? Calculate the limiting molar conductivity of any electrolyte from the individual ionic conductances. Okay, the next one is degree of dissociation of weak electrolyte, and the next calculating KSP in solubility product of sparingly soluble salts. Okay, right. I will tell you few more things after discussion of 1 or 2 PYQs here. Right. Look at here. Look at this question. What they are saying? The limiting molar conductivity means the limiting molar conductivity of 0.027. Yes, we will come back to this. Let me give you one basic question first. Okay, this is also need time. Then next the conductivity of 0.01. Okay, degree of dissociation, right? 11. Okay, you want few more minutes. Yes, look at this. This is a little easier question. Now see the limiting molar the molar conductances of NaCl, HCl and sodium acetate at infinite dilutions are given in this way. Okay, then they are asking the molar conductance of acetic acid. What they are asking? Molar conductance of acetic acid at infinite dilution is. See, this is a NEET 2021 question. It is very easy. I will explain you. Follow this step. What they are asking for acetic acid now? So limiting molar conductivity of acetic acid is equals to, what are the ions we have? One is acetate ion from here, one is acetate ion and other one is H plus ion, right? So what you need to do? So del infinite of acetate ion. So this acetate ion value they haven't provided, but sodium acetate ion they have provided, no? Yes, this is a strong electrolyte. Just take that as it is, sodium acetate. Yes, after this add place and you need to add H plus ion concentration. They haven't given direct H plus ion, but they given as HCl, that is a strong electrolyte, no? So take it here like del infinite of HCl minus, what are the extra parts you have? You only wanted acetate ion, H plus ion, but there are some extra ions like sodium ion, chloride ion, remove them as minus del infinite of NaCl like this. Okay, that's it. So that what will be your answer here? So just say here acetate ion, sodium acetate ion is how much? 1, 2, 3. So 1, 2, 3. So 91 is a value for your sodium acetate. Okay. The next one, HCl, second value is how much? 426. Right here 426.16 minus for NaCl, that is the first value here, 126, that is 126. Okay. So how much you will be getting here? 126.45. So this is 426, this is 126. So remaining will be how much? 100. 100 plus 91 is 391 right now. So we are getting answer around 391. So where do we have the nearest option here? Okay, look at these 4 options. Where do we have? Yes, our first option will be a perfect answer for the question, right? Is this clear or not? Yes, I hope the discussion is clear. Right. Let us show me few more questions. Let me give you. Yes. So tell me, for this question, this is a JEE mains question from 2021 paper. Right. Those who are in live session, please answer me. What will be your answer for the question? Yes, tell me, anyone in the chat box can answer me this. Right. So you can try this. What they are asking? The limiting molar conductivity of barium sulfate. Very easy, guys. Just take limiting molar conductivity of that barium is sulfate, no? So BaSO4 will be equals to limiting molar conductivity of barium ion. Do they given barium ion conductivity value? No. So you just check molar conductivities at infinite dilution for barium chloride they have given. So where do we have barium chloride value? This first value right now. So you can write here barium chloride. Okay, barium chloride. Let us write first, and the next one, sulfuric acid they given, because sulfuric acid provides a sulfate ion, and those two are strong electrolytes only. Yes, then you can take sulfuric acid. Okay, and what are the extra points here we have? One is chloride ions here and H plus ion. So now what do we need to do? You need to remove that extra points. What are the things here? We have H and Cl. How many chlorides are there? 2. How many hydrogens are there? 2. So you just remove 2 HCl minus 2 HCl. That's it. So just take the values over here. So BaCl2 value is how much? It is 280. Take here 280 plus sulfuric acid value is how much? Sulfuric acid is 860. Yes, take here 860 minus 2 times of HCl. How much for HCl? It is 426. That's it, 426. Okay. So will you do it and tell me your answer? Just try this. 280 plus 860 minus 21458. Okay. That means 288 minus 860 minus 852. That is 8, right? So plus 8. Okay. It means this is 280 now. So this is 280 plus 8, that is 288 will be your answer for the question. Okay, right. So this will be your answer. See, this is an integer type question. How easy it is? This is a JEE mains question. Guys, is this clear or not? Guys, if this is clear, just click on the like button and you can mention your queries or any doubts in the chat box. If it is clear, just mention clear. Right. Let me give you 1 or 2 questions as a practice purpose. Just look at here. What will be your answer for this question from JEE mains? Okay. And one more question as a practice purpose. Yes, this is again one more. So take this and tell me your answers for these 2 questions in the chat box. I will be looking into it definitely. Based on your response, whether it is correct or not, no issues you mention, I will be looking into it. If it is incorrect, I will guide you how to do. If not, I will definitely make it correct. If it is any wrong, if right, no issues. Then look at the other questions. See, they are asking about what is dissociation constant. Yes, we will be doing them. Just hold on few more minutes. Let us discuss one more application here. So first application is done. The next second application we will be discussing degree of dissociation of a weak electrolyte. See, degree of dissociation means we are indicating with symbol alpha. So for example, I am saying HA is a weak acid, right? So now it will dissociate as H plus and A minus, but this dissociation is not 100% right now. So from the degree of dissociation and looking at their ionic conductivity values, for example, del naught M is a molar conductance at infinite dilution and del M is a molar conductance at some M concentration. This is at infinite dilution, that is at 0 concentration. 0 concentration means we know there will be maximum conductivity right now. So you just take alpha as a ratio of molar conductance at infinite dilution. See guys, I am using 0 or I am using infinite, both of them are same. Del M, del naught M and del infinite M, both of them are same only, do not get confused. Okay. So here I am writing del infinite M in the denominator because this is the maximum value and del M is some molar conductance at some M concentration, you can remember. Okay. At this particular concentration, what is the degree of dissociation? Yes, this is the formula you can use. Okay. So degree of dissociation equals to what? Del M by del naught M or del infinite M, that is it. Molar conductance at some particular concentration by molar conductance at infinite dilution. Okay, that is it. This ratio gives you degree of dissociation alpha. Okay, right. So you can do it for even equivalent conductance also. Okay, both of them give you alpha value. Okay, right. Now let us see some applications of these. Look at this guys, what they are saying, molar conductivity of 0.027 molar. Okay, so concentration is given as 0.02 molar, 027 molar. Methanoic acid is how much? So del M value is mentioned, del M is equals to 40.42, right. Next, the value of dissociation constant. It means what is this dissociation constant? See, it's a methanoic acid now. So methanoic acid means how do you write? That is nothing but formic acid, you can say. OH. This is what methanoic acid. Okay, right. So if it is undergoing dissociation, methane means how many carbons? 1 carbon now. So 1 carbon is there, respective acid will be formic acid, that is nothing but our methanoic acid. It is a weak acid. What I am saying, this organic acid is a weak acid and gives you formate ion like H plus ion. Liberation of this H plus ion is taking place and this is a formate ion. Like this it is forming now. So since it is a weak electrolyte, there will be something called acid dissociation constant or Ka. Okay, that is what they are asking. Dissociation constant, yes, Ka value they are asking. Ka of this acid. So now how can you do this? If you know this Ostwald dilution principle, it is very easy. If not, look at here, I will be explaining once again. See, for example, I am saying the concentration of this formic acid as a C. Okay, here 0 and 0 at a time t0. This is at infinite, at initial. So after some time t, so this concentration is getting decreased. It means some amount of reactant converting into product. So you can write C minus C alpha. Product concentration is C alpha and this is also C alpha. Next Ka will become now what? Ka will be concentration of ion, that is formate ion and H plus ion by concentration of products by concentration of reactant by this acetic acid, like this by this formic acid. Okay, like this you need to mention. Now what is the concentration for this acetic like formate acid, formate ion, that is C alpha, and for H plus ion also C alpha, and in the denominator that is C minus C alpha you can write as 1 minus alpha. That's it. So CC getting cancelled, then you have C alpha square by 1 minus alpha is equals to your K, acid dissociation constant. That's it. Okay, up to here you got it now. So now you have our C value, how much C it is? 0.027 you can write there. But what about alpha? So how do you get this alpha? So if you know the alpha value, then only you will get your Ka. So how do you calculate this? Very easy guys, just follow these steps. I will tell you, just follow these steps. See, alpha can be calculated, just a previous slide only we discussed. Alpha is nothing but it's a ratio of limiting molar conductivity in the denominator and in the numerator molar conductivity at that particular concentration. Okay, this is a ratio. Now here if you observe the molar conductivity, it means at this concentration this is the molar conductivity. So in the numerator value we have 40.42. What about denominator? This is limiting molar conductivity now. So how do you write that limiting molar conductivity? Yes, you can see the data provided here, limiting molar conductivity of H plus ion is 350, we already studied, and formate ion is 54. Yes, so based on that you can say formic acid limiting molar conductivity will be taken as formate ion and H plus ion. Ionic conductance of this H plus ion and ionic conductance of this formate ion. Okay, right. Now what are the values they have provided? They provided it as 349.6 plus 54. Just add them, you will be getting around 404. How much you will be getting? Around 404. So this is if you see this is 40.4 now, so this will be around 404.2 you will be getting. Okay, so this is the molar conductance, limiting molar conductance of this acid. Right, you got everything here. So del naught is how much? 404.2. So this is how many times? This will be 10 times, right now 10 times, right here 10. So alpha value how much we got? 0.1. That's it, we are almost done with the question. Since we have 4 options, you will get nearest option even if you ignore this value, or if you want you can take C. Ka equals to C value is how much? C value is 0.027. So I am writing 27 into 10 power minus 3 and alpha value as 0.1, that is nothing but 10 power minus 1. 10 power minus 1 square here, right, square, and 1 minus alpha means 1 minus alpha is 0.1. You can get 27 into 10 power minus 2 plus minus 5 minus 3, you will get minus 5. Okay, and in the denominator you have 0.9. Okay, so you can write 0.9 as a 9 into 10 power minus 1 now. So you can remove this point and you can remove this and you can write it as 10 power minus 4. Right, you are almost done with the question. You will be getting exact answer here. See, Ka will be equals to now 9 3s are 27. So 3 into 10 power minus 4 will be your acid dissociation constant. So do we have any option? Yes, option D is your answer for the question. 3.0 into 10 power minus 4. Hope the discussion is clear, right guys? If the discussion is clear, just hit the like button once again. Alright, if you are new to this channel, just subscribe also. Okay, right. Next I will be giving you few more questions after this. Yeah, will you try this? Yeah, you can try this, or else yeah, you can try this question. The conductivity of a solution, yes, conductivity of a solution they are asking. How do you calculate this conductivity? Just try these questions. I have shown you 2 questions. I want answer at least for one in the chat box for these questions. Right. So guys, look at here, just tell me what will be your answer for the question. Right, see here the conductivity of a solution of concentration 0.1. So what is the concentration of this weak acid? HCl weak acid concentration is 0.1. Okay, and they are saying, they are asking us to calculate K. How do you get this K now, tell me? They are given limiting molar conductances. So how do we get this? Conductivity of a solution of 0.1 mole per liter of a weak monobasic acid is they are asking. So K they are asking and limiting molar conductances are given. So how do we do this? And degree of dissociation also given, right? It's very easy. What is the degree of dissociation value mentioned? So alpha value is 0.02. And the next, what about the other data mentioned? This is del naught of A. It means limiting molar conductivity of weak acid HA is how much? 400. That's it guys. Almost we are done. What they are asking us? They are asking about K. Okay. Now using this we can find one thing. What we can find? Lambda is equals to del M by del naught M. Okay. So from this we can get our del M. Now there is a relation between del M and K. What is that relation? Del M is equals to K into, okay, K into, they are asking in centimeter inverse, so K into 1000 by M. So we have our concentration, M we have, and what about K? That is what we need to find. Del M we are going to get here. So what is this del M value? Del M is nothing but alpha into del naught M. So how much? 2 into 10 power minus 2 multiplied with 4 into 10 power 2. You can remove this 8. Okay, you got del M as 8. The next what we need to do, this is 8 and molarity is 0.1, just send here, this is 0.1 and this is 1000, just send into the denominator here, and this is K. So now how much you got? 8 into 10 power, this is minus 3 if I write in numerator, again already we have 0.1. So 10 power minus 4. So K is how much now? 8 into 10 power minus 4. That is your answer. Okay, right. Right. So next question is on yes, tell me for this in the same manner. In the same way you can do this. Whatever the steps you followed previously, follow here. If the degree of dissociation of formic acid is given, the molar conductivity of its solution is very easy. Just one step question it is. What they are asking us to find? If the degree of dissociation of formic acid is given. So alpha value is how much? 11%. It means 11 by, you can write 0.11 also, it's your wish. The next what they are asking, the molar conductivity del EM they are asking. If they simply mention conductivity, that is kappa, K. But they are saying molar conductivity means del M. Now, they are also given provided some data also. You just see here infinite dilution, limiting molar conductivity of H, and that formate ion is mentioned. So from that you will get limiting molar conductance of that formate. That's it. How much it is? COOH is 349. So 349 plus this you will be getting, just add these two values, you will get 404.2. That's it now, 404.2. You got this value, and you just, they are asking this. Yes, there is a relation between alpha, del M and del naught A.
Alpha equals to del m by del
Yes, alpha equals to del infinite m or del naught m in the denominator and here del m. So tell me now, from this del m will be 11 by 100 into 404.2, that is nothing but you will get it as 4.04. So 1144 you will get. Where do we have 44 type of answer? Yes, 44 type of answer, we have these two answers as 44.46, right? Those are our answer, but particularly one answer only. Look at the difference. Here units is meter square, SI units, CGS units. So you just look at our data provided is
centimeter.
So this is CGS. So answer should also be in the same one. So B. Okay. See, there is a trap here in the first option itself. So option B will be your answer. Be careful while answering. Right? Clear now? This is already discussed. Can you answer me this? Very easy. Try this and tell me. This is the first application that we discussed previously. Direct formula substitution only. What happens? I want to get the molar, limiting molar conductivity of this acid. So what to add, what to subtract? I want this acid, like this anion and H plus. So add 1 plus 3. What to add? 1 plus 3, because anion is coming from here, cation H plus is coming from here. The extra ions are what? Sodium ion, chloride ion. So sodium chloride you remove. So 1, 2, 3 if you make 1 plus 3 minus 2, that's it. 1 plus 3 minus 2. Okay, so you just tell me your answer for this. So we have any option? Yes, that will be your answer. If you got that answer, yes, that is perfect. Next. Will you do this the same way? Limiting molar conductivities of these ions are given and they are just asking for AGI. How do you do? AGI means take them as 1, 2, 3s, add required, remove unnecessary things. So AGI means 1, 2, 3.
14.
So 3 plus 1 minus 2.
3 plus 1 is 26, 26 minus 2.
That's it. You can get the answer, right? Next. Tell me, how can you do this?
Alpha del m by del naught m.
Molar conductivity of this 0.07007 molar acetic acid is this much. Del m is given 20. Next, what is the dissociation constant of acetic acid? Dissociation constant means Ka. Okay, so how do we get this Ka? And they have provided extra data, that is about limiting molar conductivity. So from this you will get a del naught m. How much del naught m? 350 plus 50, 400. Yes, this is you got. Then next, what is the use of this data? See, Ka, what is our formula we got? Just now I told you about Ostwald dilution principle also. You will get an equation like C alpha square by 1 minus alpha. Okay, let us substitute the values over here. What is the concentration mentioned? 7 into 10 power minus 3. Okay, into alpha value mentioned is how much? Alpha is nothing but del m by del naught m. See, most of the questions are based on alpha relation. Okay, right, related to Kohlrausch law. The next here 420. So it will be 1 by 20. So this is how much? 1 by 20 means 0.05. See, 1 by 20. So 0.1 by 2 means 0.5. Okay. So here 5 into 10 power minus 2 power 2. And in the denominator 1 minus 0.05. Okay, let us ignore this denominator. We will look into only numerator because we will get a nearest value here anyways. So how much we'll get? So this will be 7 into 25, 7 into 25 into 10 power minus 3 plus minus 4, that is minus 7. How much it is?
75.
This one, 175 into 10 power minus 7. Yes. So you can make it as 1.75 into 10 power minus 5. So we have option 2 as our answer for the question. Perfect now? Right. Do this question. The conductivity of a weak acid HA of a concentration is given. The ionization constant K is also given. Yes guys, already I have discussed similar manner question. Just tell me this answer for this question in the chat box. Those who are watching in live session, give me your answer.
Sir, is it conductivity or molar conductivity?
They are saying conductivity of a weak acid is that much. K is provided and the next concentration also provided. The next what they are asking? Limiting molar conductivity also provided. They are asking about Ka they are asking. So what do we mean by Ka? C alpha square by 1 minus alpha. It means they are asking about acid dissociation constant. No? So you got C, you have C, you need to only find alpha. How do you get alpha? Alpha comes from del m by del naught m. Del naught m data given 190 plus directly they given 190 given del naught m. So you need to get your del m. So how do you get del m? Using your K.
Del m equals to K into 1000.
Yes, that's it. K into 1000 by molarity. That's it. Can substitute the values of del m, del naught m, get alpha, substitute here, you will get your K. That's it. Okay, right. Next, one more. K value is here 2 into 10 power minus 5. One more very easy question, but a NEET question. Previously it is JEE question. Just tell me for this. NaCl, HCl and acetate ion is at infinite dilution is given. Then molar conductivity of acetic acid, very easy now. Acetic acid can be made by adding acetate ion like this one. So 1, 2, 3, 5 say. So 3 plus 2 minus 1, that's it. Put the values, respective values. 3 means 91 plus 2 means 426, 1 means 91, 1 means 126, that's it. So it will be 391, around 391. See, same question asked second time. This is second time. Okay. What is your answer? 391. That is nearest one is 390.75. Okay. Right. Next thing here to discuss is look at this question. It is little interesting and tricky question to solve. Just tell me what is your answer?
They're asking for an H full OH. So 3 plus 1 minus 2.
Be careful whenever they ask for molar conductivity. For example, if I am saying molar conductivity of BaOH twice, so it will be written in this manner. Be careful, you should write in this manner. So ionic conductance of limiting molar conductance of barium plus 2 ion plus there are 2 ions now, so 2 times of OH minus, like this we need to write. Okay, but if you look at the question, what they are asking, the molar conductivities of limiting molar conductivities of BaOH twice BaCl to NH4Cl is given. They are asking for limiting molar conductivity of this weak base, that is ammonium hydroxide. So it means limiting molar conductivity of NH4OH. Now how many OH groups are required to construct this formula? 1. But BaOH twice is contributing 2. so we do not require 2, so we should take half of it. So what I am taking here, half of molar conductance of BaCl BaOH twice, just be careful here what I am using, BaOH twice plus next what I want, I got our OH minus ion, only one I want, here 2 is there, that is why I am dividing with 1 by 2. Now I want one more is NH4 plus. NH4 plus can be contributed by this NH4Cl. Okay, so it means one NH4Cl is giving only one NH4 plus ion. So
2 for
NH4Cl. Next, what are the extra ions you are seeing in these?
Cl.
Huh? In the first case it is barium, in the second case it is Cl. Okay, so it means you should remove this barium chloride. See, if it is one barium chloride contributing 2 chloride ions, so you should not take BaCl2 directly. How much you should take? Here half Ba you are removing, and you want only one chlorine, it is giving 2, so it means you should take half BaCl2. So solve now, what is the values they have given? 1 by 2. For BaOH twice they are saying value as
457.
just tell me here what I should write here. BaOH types first value is 457 place for NH4Cl
40.6.
last value, this is how much? This is 2130. How much it is? 2130. Okay, 2130. The next one more value minus half into BaCl2 is how much? The middle value 240.6.
120.3.
6. So what you need to do? So this will be 120.3. This will be 2 times 228.5. So you got your answer finally. How much it is? 228. 0.5 plus 2130 minus 120.3. Just tell me how much. So here if you subtract you will get 2010 almost, and this is 228.2. Tell me, just add these two numbers.
2238.2.
28322, right? This is the answer. So how much it is? 2238. Yes, 2238.2. So fourth option will be a perfect answer for the question. Exact answer we got. That's it. Okay. Next, a few more questions I just want to add here. See, these are the questions from yesterday's discussion. You just read them and you can practice them just for practice purpose. If you are unable to answer, just watch the previous live session, that is yesterday's session. Okay, one more question also. Yes, this is again from NEET. And next, let me give you few more things. See, this is the data I am providing. This is the data of all the ions I am providing. Then calculate, it is again for practice purpose. Calculate all these things. How do you calculate? Tell me. See, they are asking about equivalent ionic equivalence of, like equivalent conductance of aluminum ion they are asking. Like this. Okay, how do you get this? Yes, we need to know the relation between del M and del N. What is the relation we did yesterday? How can you get this? See, del M is nothing but K into 1000 by molarity, and del N is nothing but K into 1000 by normality. Just take the ratio of those two things, numerator removed. The next what we have? Del M by del N is equals to, this denominator goes to numerator N, and here it becomes M. Okay, so now N can be written as, normality can be written as molarity into N factor. So molarity removed, del M by del n can be written as
N.
n factor. Okay. So now if you observe this, this is the relation we have. They are asking about del equivalence. It means del n they are asking. So how do you get this?
By N factor.
So they have given molar conductivity of that aluminium plus 3 as del m is mentioned as for aluminium plus 3 as 300. Okay, what is the n factor for aluminium? What is the charge present on it? That will be its n factor, right? Now tell me, del m by n factor is equals to del equivalent from here, from this relation. So how much is your answer? Del equivalence equals to 300 by 3. It will be 100. So equivalent conductance of aluminium plus 3 ion is how much? 100. Okay. In the similar way, you can calculate for aluminium sulfate and ammonium sulfate, and next all these chlorides, sodium chloride, barium chloride, and for water no need of considering. Okay. Then next for this alum also and for this NaCl also. Okay, right. You just calculate all these things and mention the answers for them in the chart box. Okay, I will be looking into it. Okay, so thanks for watching. Stay connected with our NEET World channel. Thank you. Any doubts, Adora?
అక్కడ 2 into